Hello and welcome. This is Steve Suffoletto from State University of New York at Erie, often referred to as SUNY Erie. We used to be called Erie Community College, or ECC. Today's presentation is about press speeds, and it's titled, Just How Fast Is That? So the speed of a press will be determined by its paper handling method. There's two ways you can do that, by Sheetfed and by web. So Sheetfed offset lithography prints on individual sheets. So we talk about sheets per hour, SPH, or we talk about impressions per hour, IPH. Now Sheetfed presses are slower than web presses because you have to pick up the sheet, stop the sheet at the head stops or front stops, sometimes called lays. Then you have to pull the sheet over into position with the side guide and then insert it. Today, with current technology, maximum speed on a sheet-fed press is about 20,000 sheets per hour. And that's for a 40-inch or 102 centimeter press. On a web press, whether it's heat set for magazine printing or cold set for newspaper printing or flexography or gravure, they're much faster because they run off of a continuous roll or a web. The maximum speeds here can be 80,000 copies per hour or 3,000 feet per minute. And then of course we have digital copiers or printers. These are so slow we express them in pages per minute, ppm, and they can be as slow as 15 pages per minute or over 90 pages per minute. And they're typically limited to tabloid size, 12 by 18 or 13 by 19 inches. Laser printers, electrophotographic or xerographic, are the slowest. Print production lab, we have Ryobi 2800 and 3200 duplicator presses, and their maximum speeds are 10,000 sheets per hour. Let's define what speed is. Speed is distance divided by time, or using simple abbreviations, S equals D divided by T. So the distance units can be either metric, meters, or they can be imperial, miles, or feet, or yards. And the distance is the sheets per hour or impressions per hour. Sometimes we talk about their cutoffs, copies per hour. It could also be feet per minute or meters per minute. It could also be revolutions per minute, RPMs. So this will depend on the size of the cylinder diameters, their circumference, their repeat length, or their cutoff. And then of course, T is for time, whether it be seconds, minutes, or hours. The reference speed in the United States is a mile, and it's very familiar to us because when we walk or ride a bicycle or drive a car, it's always in miles. 1 mile equals 5,280 feet, or in metric, 1 mile equals 1,609 meters, and 1 mile is also the same as 1.6 kilometers. And 1 kilometer is 0.62 miles. An average adult person walks about 3.1 miles per hour, or about 272 feet per minute. So let's do some speed conversions here. I want to go from feet per minute to miles per hour. So using algebra, we can perform speed unit conversions with cross or diagonal multiplication to cancel out the units. So here we have feet per minute times 1 mile equals 5,280 feet times 60 minutes and 1 hour will equal miles per hour. The feet per minute cancel out because this foot cancels out with that foot, this minute cancels out with that minute, and all you're left with is miles on the top numerator divided by hours on the bottom denominator for miles per hour. There's 60 minutes in an hour, and there's 5,280 feet in a mile, so the conversion factor is going to be 0.0114. The equivalent speed of 1,000 feet per minute is 11.36 miles per hour. Living in Buffalo, New York, we're very close to Niagara Falls, and we often travel over to the Canadian side. And in Canada, they use the metric system. So we have to be careful about our speed so that we don't get a ticket by the police. 100 kilometers per hour is equivalent to 62 miles per hour. Okay, now let's do the speed conversion from feet per minute into meters per minute, more commonly used on web presses. So we know 1 meter is equal to 3.28 feet, and we know that 1 foot equals 0.3048 meters. So if you do the algebra, the conversion factor will be 0.3049. 1,000 feet per minute is equal to 304.9 meters per minute. This conversion was simpler mathematically because we did not have to convert the time units. The former and the latter were both in minutes. Let's look at counting speed. Is there a way we can calculate impressions per hour or sheets per hour by just counting the seconds? Well, there is. There's 60 minutes in 1 hour. There's 60 seconds in 1 minute. So 60 minutes per hour times 60 seconds per minute equals 3,600 seconds in an hour. So what is a short counting time in a convenient mental math conversion? Well, it's 3,600 seconds divided by 9 seconds would equal 400. If you count 25 sheets during 9 seconds, then that speed is 10,000 sheets per hour. 25 sheets counted over 9 seconds times the 400 conversion factor equals 10,000 sheets per hour. So on web presses, the web is moving very fast. So you can physically inspect the sample at the end of a row splice because there is no motion. It's stopped. But can you inspect the web real time while the press is running? At fast press speeds, the web will be a moving blur. So you can stop the motion with rotating mirrors, old technology, or you can stop the motion with a strobing light flashing, old technology, or you can stop the motion with a video camera. So this is the current technology. An example would be an AVT video camera. AVT is Advanced Vision Technology. This camera allows you to move in both X, Y directions to any location on the web, and you can zoom in or zoom out to different magnifications and get high resolution detail so that you can check for any quality or print defects like being out of register, hickeys, voids, specks, dirty print, all those types of defects. So let's talk about some relative speeds here. You just saw Superman fly across the screen there, and you remember you were a little kid back in the 1960s watching the Saturday cartoons with Superman faster than a speeding bullet. So in photography, you're going to get motion blur. It looks like the object is out of focus with a streak or a smear. This will depend on the speed of the object, the observer viewing distance, and the camera sampling rate, which would be your shutter speed. So a gun bullet travels at about 900 miles per hour. So a .22 caliber bullet can travel between 400 and 1,000 meters per second. Now, of course, this depends on the size, the shape of the bullet, and the length of the gun barrel, whether it's a pistol or a rifle. Let's look at a jet plane. If you're on the ground and you're looking up in the air and a jet plane is flying, it's moving very fast, over 600 miles per hour, but the viewing distance is 30,000 feet altitude, so it's about 5.5 miles away. When you think about the moon at night looks like it's following you, it's standing still, and that's because it's very far away. It's over 250,000 miles away. Think about being on the Earth. The Earth is spinning on its axis at the equator at about 1,027 miles per hour. With a camera, the shutter speed, if you decrease the shutter speed, objects that are in motion will start to blur. You often see this as a special effect in photography for cars driving with their headlights, water flowing through a stream or a river. Now, if you want to keep an object in focus, you can pan. So this is a photographic effect called panning, where you follow the object. It keeps the object in focus, and the background is in blur. So in summary, let's watch this tortoise versus the hare, the turtle versus the rabbit. So the speed of a printing press can be in any units. Those units can be easily converted from this unit to that unit. Speed is important for productivity and profitability. However, you don't want to compromise quality for speed. it's better to run slower with better quality than it is to run faster with lower quality. You want to avoid any customer complaints and rejections. Sheet-fed presses in general are 1/3 slower, and web presses in general are 3 times faster. Once again, this is because a sheet-fed press has to stop the sheet and then side guide it. A sheet-fed press can inspect a sheet at any time. All you have to do is pull a sheet out of the delivery gate. However, on a web press, row to row, you need to have a camera to check the blur motion of the fast-moving web so you can check for print and quality defects. As usual, thank you for your time. I hope you found this presentation interesting, informative, and useful. If you liked it, please share it with other people. Until next time, have a good day. Bye now.